lecture is about collusion. Okay, so we're going to be wondering whether profits are going to be higher or lower than profits under Cournot. Okay, so remember with what we did in the last lecture with that Krebs-Schenkman stuff, we gave reasons why profits might be lower than under Cournot. Okay, because rationing isn't actually efficient, and if rationing is close to proportional, then you get an outcome that's closer to perfect competition. Okay, and this is what Davidson and Danekera showed. Okay, so that's the Davidson and Danekera argument is one reason why you might expect firms to make lower profits than those under Cournot competition. But what if firms can collude? Okay, collusion is one reason why you might generally expect very high profits. So we're going to be looking at collusion and how collusion can be sustained between firms. Okay, so with Cournot or Bertrand competition, the price is always below the monopoly price. So aggregate industry profits are below the highest they could be. Okay, monopoly price corresponds to the highest profits that industry profits could possibly be. So if you like all these firms competing in either Bertrand or Cournot competition, they'd like to collude and set the monopoly price. Okay, but that's not sustainable because if one firm sets the monopoly price, another would want to undercut under Bertrand competition or produce extra quantity under Cournot competition. So we need some way of being able to sustain the collusion. Yeah, and what's driving this? Well, it's this business stealing effect under oligopoly. When a new firm enters, it's not internalizing the effect it's having on the price of other firms. Okay. So relative to the goal of maximizing industry profits, each firm is going to produce too much. Okay, because each firm only cares about its own profits, not about aggregate industry profits. So each firm has this incentive to produce too much relative to the goal of maximizing industry profits. So it's a bit like a kind of prisoner's dilemma outcome. Okay, everyone would like to collude on the cooperation outcome, which is everyone setting the monopoly price. But if everyone else is setting the monopoly price, you want to set a lower one, or you want to produce extra quantity. So in the real world, collusion seems fairly widespread. Okay, so there are some very famous ones. Okay, and there are some examples given in Shine 5.4. So the OPEC cartel is the cartel of oil-producing nations. I guess if you do the energy economics module, you might have talked about them. So they collude to keep oil prices high. Okay, they restrict the supply of oil in order to keep oil prices high.
Not very well.
Pardon?
Not very well.
Not very well at the moment, it's true. Oil prices are plummeting. And it's partly because new countries are coming on board with significant output who aren't in the cartel. So what a cartel would like to do? Well, a cartel would like to act as one big firm. Okay, a cartel would like to maximize joint profits of everyone in the cartel together. Okay, so the cartel kind of acts like a monopolist. And competition law means this is generally illegal. Okay, so colluding in the way that OPEC colludes is illegal in most countries. Okay, you can't have Sony and Apple colluding over phone prices in this explicit way, where they're deliberately trying to maximize joint profits. So this kind of open agreement is certainly illegal. Secret agreements are also illegal, but they're much harder to prosecute, right? So there was a famous secret agreement between Sotheby's and Christie's in the 1990s. Okay, these are two big auction houses. And it's almost hard to believe what these guys were doing. Okay, so the CEOs of the two companies were meeting in secret, and they were agreeing on common charges for commission. Okay, so they were both agreeing to set high commission charges. So the commission is the percentage of the auction price that goes to the auction house. And they did things like sharing client lists in order to in order to know if anyone was negotiating other rates. If you know everyone who's buying from the other client, then you can monitor what's going on a lot more effectively. So you can make sure that no one's breaking the collusive agreement. So by sharing all this information, they made it easier to check that the other one wasn't deviating from the collusive agreement. And eventually someone from Christie's got a bit worried about this, and they thought they'd cover their own arses, so they snitched, if you like. So Sotheby's got a $65 million fine. And the CEO personally got a $7.5 million fine. So it's quite a bit for an individual. So,
did Christie suffer anything?
Christie suffered less, I think. Do I have it on the next slide? They still got some fine. And he got a year in jail as well, so there's some justice involved. That's good. They paid customers a heck of a lot of money. Okay, so that's one very famous example. Another one is the vitamin cartel. So Hoffman La Roche is a French company. They make some skincare products as well. Swiss. Sorry. Okay. Basf, I remember Basf used to make audio tapes. You're probably too young to remember tapes, but Basf used to make tapes. Anyway, apparently these guys all made vitamins, and they're doing the same thing. They're exchanging sales data, price fixing, and it was a huge case. $500 million fine for Hoffman La Roche. $250 million for Basf. So prison time for the CEOs as well. Yeah, LIBOR is a more recent one. I don't know. To be honest, I don't see LIBOR as that much of a problem. I think people were stupid for
getting caught.
No, for ever pegging anything to this rate. So if you look at how LIBOR was set by a bunch of people just deciding on a rate in a room. It was not a market rate. Why on earth would you peg anything to that? It's your own fault for pegging things to that. So I'm not too sympathetic to that. But this is something different. Okay, so these secret agreements, clearly illegal. You have to work quite hard to sustain them. In order to sustain these agreements, they were exchanging client lists, sales data, just to prove constantly that they weren't breaking. So it's not easy to sustain this kind of thing. So we're not going to talk too much about this type of collusion. To a certain extent, it's obvious what colluding firms were doing in that world. If you can really trust the person you're dealing with, exchange all this data, then you just set the monopoly price. It's not that interesting, and it's illegal, so you hope it doesn't happen too much. What's going to be much more important is a kind of a tacit agreements that you see a lot of. So, so here I say, most shops selling Sony TVs, they're going to charge the same price for those Sony TVs. Marginal cost for a Sony TV will be a tiny fraction of that price. But somehow these firms are all managing to agree to set the same price. Go on.
Isn't that a bit different because of the RRP?
Well, that itself is, yeah. The RRP is just a suggestion. It's just a focal point. Why would you follow that RRP? Are you really worried for so? Yeah, because everyone else is. Okay, so that's the kind of a tacit collusion that's going on. So what we're going to model is we're going to model it as a dynamic game. Okay, everyone's going to be setting the collusive price, and if people deviate from setting the collusive price, they're going to be punished in some way, and that punishment is going to mean that they'd rather not deviate to start with. Okay, so rather than just having a one-shot competition, so Cournot or Bircham competition now and then nothing in the future, we're going to have multiple periods, and there's going to be competition in each period. So maybe I've said this already to a certain extent. It's not obvious how collusion is possible. If my rival's selling pills at £1 per pill, I'm always going to be tempted to sell them at 99p, if possible. So there has to be some way of punishing people who deviate. And what's going to be a common way of punishing people who deviate? is going to be reverting to marginal cost pricing. Okay, so if anyone deviates from selling for monopoly price, everyone's going to revert to marginal cost pricing for some number of periods. Okay, everyone loses out from that, because you know you're going to lose out from that, you don't want to deviate in the first place.
Couldn't the larger firms set below marginal cost to kind of force the smaller company like to go bankrupt, and then so then they're like prepared to accept losses for X amount of periods just to kind of get rid of them? They do that as well.
Yeah, and there's some evidence that Amazon have done that. So it's always quite hard.
Loss leaders.
Yeah.
Anti-competition.
Yeah. So.
Yeah, they can't price below marginal cost for a very long period.
Are you seeing all found the same marginal cost?
Not necessarily. Okay, so when firms start pricing below marginal cost, that's clearly quite painful for them. It's not something they can sustain for very long. It's not something they want to sustain. So maybe a threat to price below marginal cost might not be that credible a threat. You know, I guess for probably some circumstances where it could be made credible, but you have to be a bit careful. Okay, so what we're going to be arguing is that collusion is a dynamic phenomenon. It's about doing something now because you're scared of getting punished later. So one thing you might think about doing is, well, let's just have a finitely repeated Birching competition or Cournot competition. Intuitively, do you think finitely repeated Birching competition will give you a price above marginal cost?
Depends on how good the punishments are.
Well, the punishments is making zero economic profit versus making supernormal profit. So one period they can make lots, and the next period they make nothing if they can. So they'd rather go for supernormal profits in one period.
The final periods are always cheap.
So they know that they're going to...
Okay, so now we're on the right line. So he said that in the final period they'll always cheat. And this is exactly the problem. If you have finitely repeated gain, you know that in the last period, you can't possibly punish people in the last period. So after the last period. So in the last period they have to play the normal equilibrium. So in finitely repeated Birching competition, the last period has to be priced as marginal cost. And in finitely repeated Cournot competition, the last period has to be, the standard Cournot outcome. So if that's what's happening in the last period, well, what's going to happen in the period before? You know, you're going to be pricing marginal cost for next period, whatever happens. So you can't really punish people in the period before either. So the whole thing is going to unravel backwards. Okay, so if you have a finitely repeated game by a backwards induction argument, you just get the same outcome as you do in the original game. Okay, so in order to sustain collusion, we're going to need an infinitely repeated game. And that's, I guess, what I'm just saying on the slide. So you can think about prisoner's dilemma as well. Finitely repeated prisoner's dilemma. In the last period, people are going to defect. So given that in the period before, people would want to defect, and so on. So what about an infinitely repeated game? Okay, so let's just look at Birching competition. This is 651 in Alshai. So we're going to have infinitely many periods. So time is going to be 0, 1, 2, 3, 4, etc., etc. We're going to be n firms. Each firm is going to have the same marginal cost C for simplicity. With some market demand curve. Monopoly profits. If there was only one firm in the market, it would make a monopoly profits of pi m. Okay, we're not bothering to solve for what pi m is, we're just specifying some number pi m. And this corresponds to setting a price PM for monopoly price. Okay, so what people would like to do is they would like to collude and all set the monopoly price, and then share monopoly profits between them all. The monopolist problem is just quantity times price minus cost, given the standard first order condition. So you could solve, if you knew what Q was, you could solve for PM if you really wanted to. Okay, so what's going to happen in this game? Well, at each period, each firm is going to simultaneously set a price. And they're going to do that to maximize their expected discounted profits. Okay, so they're forward-looking, they care about profits in all future periods. And they're going to care about an expression of this form. So they've got some discount factor, so beta is going to be less than 1. And this is the sum from now to the infinite future of profits of firm I in period t plus s, okay, discounted by this thing beta. Okay, so you've seen similar things in macro, I guess. You see things like this all the time in macroeconomics. You know, so if beta is 0.95, and this is kind of, they care about the future 5% less than they care about the present. And what, you know, written out, this sum is just profits today plus beta times profits tomorrow plus beta squared times profits the period after, etc., etc. Okay, so this isn't too difficult. So there's one trivial equilibrium of this game. So one equilibrium is just every firm sets price as marginal cost in every period. Would anyone want to deviate from that? Well, if they set a lower price in any particular period, and they make a loss. If they set a higher price in any particular period, they just make zero profits anyway. So this is one equilibrium. It's not very interesting. Okay. The fun thing is, but for other equilibriums where people price above marginal cost. So in general, there are going to be lots of equilibria to these games, but let's just look at the one in which industry profits are highest. Okay, which, if you like, is the one that they'd like to coordinate on if they can. So let's suppose that in the first period, all firms set price equal to the monopoly price. And let's suppose that in subsequent periods, firms set a price equal to the monopoly price if they've never observed anyone else setting a price other than the monopoly price. However, if at any point in time they've ever seen someone setting a price other than the monopoly price, then they're going to price at marginal cost. Okay? So their pricing function is conditional on the history of what they've observed up to that point. If they've always observed people setting the monopoly price, they're going to set the monopoly price. If they've ever observed someone pricing below or above monopoly price, they're going to set price as marginal cost. Okay? And this is called a grim trigger strategy, because if you like, once this bad thing happens, someone deviates, you're triggering the strategy of pricing at marginal cost. And it's grim because it's kind of like you're killing yourself in order to punish other people. So these are possible strategies that firms might follow. Okay, we want to know if this is a subgame perfect Nash equilibrium of the game. So if it survives backward induction. Okay, and it's not, in these infinitely repeated games, it's not easy to do backwards induction, right? To do backwards induction, you need a last period. But we've got infinitely many periods, so we don't have a last period. Okay? So we're going to use this nice result from game theory, which you don't need to know the proof of, it's just a nice result to know, called the one-stage deviation principle. Okay, and this result says that a set of strategies is a subgame perfect Nash equilibrium if and only if there's no possible history. It's a bit complicated, isn't it? So if and only if there's no possible history up to some point t, such that in that point t, some player would like to deviate from the strategy in that period only. Okay, so imagine a possible history, any possible history that could happen in the game. And if no one would like to deviate in one period only following that history, then it's a subgame perfect Nash equilibrium. Okay, so you don't have to consider deviations in multiple periods. You only have to think about a deviation in a single period. Okay, and that's why it's easier to check. So what we're going to do is we're going to use the one-stage deviation principle to check that these strategies here are indeed a subgame perfect Nash equilibrium. Okay, we just want to check that there's no period in which someone would like to deviate. Okay, so the one-stage deviation principle was about any possible history. Okay, so we have to check it for any possible history. So there are two types of histories that we might consider. There's a possible history in which people have always priced at the monopoly price. Okay, that's one type of history. The other type of history we might observe is at some point in time someone has set a price up from the monopoly price, and then we're pricing at marginal cost. Okay? So in that second type of history, people are pricing at marginal cost, they don't want to deviate. So there can't be any one-stage deviations in that second type of history. Once everyone's pricing at marginal cost, then no one wants to deviate from that point on. Okay. So we've checked that type of history, we only have to check the first type of history now. If people have always priced at the monopoly price, does anyone want to deviate to a different price? Okay, that's what I say here. So if a firm decides not to deviate, then each period it's going to get a share 1 over n of the monopoly profits. Okay, the monopoly profits are pi m, so it's getting a share pi m over n each period. Okay. So today it gets pi m over n. Tomorrow it also gets pi over m over n, but it cares about tomorrow a bit less by beta. Okay, so in total it gets this infinite sum. And I guess you've seen these infinite sums a million times, right? So we have something like pi m over n plus beta times pi m over n plus beta squared times pi m over n plus etc. etc. Okay. So this is pi m over n times 1 plus beta squared plus beta cubed plus etc. So does anyone remember the trick for working out the value of infinite sums like this?
N and then n plus 1. Because you write it n.
Yeah, well you can do it up to n. You can. It's actually easier to work with infinite sums straight away. So,
It was divulged to 2. Is it 2?
pardon?
It was divulges to the same number when it's like that. I think it's 2.
Assuming
Because you
that
get 1 plus,
beta
oh no, it
is
tends to be
less than 1.
Yeah, so you need beta to be less than 1, otherwise this will be infinite. Okay, well let's call this thing, let's call it S, okay? So let's say S is equal to 1 plus beta squared plus etc. Okay? And let's think about what 1 minus beta times S is. Okay, so imagine multiplying out the brackets here. So you get 1 times S, and then you also get minus beta times S. So let's multiply out the brackets, take it in turns. So we get 1 minus beta, and then we get plus beta minus beta squared, then we get plus beta cubed minus beta to the 4. Okay, you see the pattern, plus beta to the 4 minus beta to the 5, okay, etc. etc. So all we're doing is we're taking 1 minus beta times 1, 1 minus beta times beta, 1 minus beta times beta squared, etc. etc. So what's this going to be equal to? 1, exactly, because 1 minus beta and plus beta cancel, minus beta squared and plus beta squared. I've made a mistake, haven't I? That's a beta squared. I got confused. Too excited. So excited. Oh. Okay. Sorry. So this is 3, this is 3, this is 4. Okay, I can't count. Okay, so these are cancelling out, these are cancelling out, these would cancel out. So this is just 1. So 1 minus beta times S is equal to 1. So S is equal to 1 divided by 1 times beta. So, you know, you can either just remember S is equal to 1 over 1 minus beta, or you can remember the trick. I always find it easier to remember the trick than remembering the formula, because Once you see it once, you hopefully remember. Okay, so the aggregate profits are going to be pi m over n, all divided by 1 minus beta. So that's the profits they get if they don't deviate, if they carry on selling for monopoly price forever. What about if they deviate? Well, again, we're only considering a deviation for one period. So today they're going to set a different price to a monopoly price, and then from then on we know they're going to be punished. Okay, so from then on they're going to be setting price as marginal cost, according to the strategy. So if they deviate today, they're going to set a price that's just 1 penny less than the monopoly price. So they're going to get the whole monopoly profits to themselves. Okay? So if they deviate today, they get pi m as profits today. In future, they make no profits. Okay? All future periods they're setting price as marginal cost.
So do we assume that epsilon is small enough to be equivalent to
Yeah, exactly.
profit?
Yeah. So they're pricing arbitrarily close to the monopoly price. So if they don't deviate, they get pi m over n in every future period. If they do deviate, they get pi m today and nothing in future periods. So for them to not want to deviate, so for the strategy to be subgame perfect, it has to be the case that profits from not deviating are higher than profits from deviating. Okay, so we need pi m over n over 1 minus beta to be bigger than pi m. Does that make sense? Okay, so we've got a pi m here and a pi m there, those cancel out. So this is 1 divided by n times 1 minus beta is bigger than 1. So let's multiply both sides by n 1 minus beta. That's just going to say that 1 is bigger than n times 1 minus beta. So this is the condition we need for the strategies to be subgame perfect. And I simplify it a bit later. So I'll just go through everything. So pi m over n 1 minus beta bigger than pi m, that's what we started with. So then we cancelled out the pi m's and we got 1 over n 1 minus beta bigger than 1. Multiplied by this, we got 1 bigger than n 1 minus beta. Okay, so now that's just n minus n beta. Add n beta to both sides, subtract 1, so that's n beta is bigger than n minus 1. So beta is bigger than n minus 1 over n. So as long as beta is big enough, the strategies we've described will be a subgame perfect Nash equilibrium. What's beta measuring? Well, beta is like a measure of people's patience. If beta is close to 1, people are very patient. They value profits in the future almost as highly as profits today. If beta is small, then they want profits now rather than profits in the future. Okay, so it's quite intuitive. In order to sustain collusion, what we need is patient firms. We need firms that care about profits in the future sufficiently highly. Because if they're too impatient, they're just going to want to take profits today, even though they know it's going to mean lower profits in the future. Pardon?
As n goes up, the patient seems to go up as well.
Yeah. So with more firms, we need firms to be more patient. Okay, if you like, with more firms, there's more competition in some sense. Firms are more tempted to deviate. We need firms to be more patient. And it's because in the subgame perfect Nash equilibrium, they're splitting the monopoly profits equally between them. Okay, so we're all getting a share of 1 over n. So if n is large, they're getting a small share of profits today. So they'd rather steal and get the whole profits. Just for 1 period. Okay, so it should be easier to get collusion when we're just a few firms, which makes sense, right? Okay, so where this beta thing seems to be very important. Where might beta come from? Okay, well, if the real interest rate is constant, okay, suppose R is the real interest rate in the world, so it's the interest rate on a 1-period bond, then if the firms are rational, they're going to set beta equal to 1 over 1 plus R. Okay, they're going to compare the profit streams they get from their business to the profit streams they would get from owning 1-period bonds. Okay. So this would be the sensible beta for them to use. So if the interest rate is high, beta is low. Okay, if the interest rate is high, it means they can get high returns by just investing in a bond. Okay, so they need so they're more tempted to deviate now, take the profits, and then put those profits in a bond to get return in future periods. That's one way to think about it.
So you should get more collusion in when interest rates are low.
Yeah, so we get more collusion when beta's high, so when interest rates are low. Okay, and if you think about, I don't know, the run up to the financial crisis, interest rates were very low, but at the same time, we had a lot of crazy pricing in financial industries. So maybe those financial industries were colluding. It's a bit of a stretch. I say one period here. We haven't specified what a period is, but it could be months or years, whatever. Yeah, let's go on. So, in reality, demand in most industries is growing over time. Okay, population is increasing, productivity is increasing, people are richer, so demand is higher. So let's suppose that the demand curve that they face in period t is 1 plus g to the power of t, so this is a growing component, times the kind of demand they face in period 0. Okay, so there's demand is product of two things, one that's just growing over time, one that's the standard demand. So, monopolist profits, quantity times price minus cost, so here's quantity times price minus cost. So the monopoly profits in period t are going to be this growing term times the monopoly profits in period 0. Okay, if you like, this bit doesn't have, there's no price in this term. So when you differentiate, this term isn't going to change the location of the maximum at all. Okay, so the location of the maximum is going to be the same as it is when profits are like that. But in fact, profits are like this, so profits are growing over time. Okay, so if demand is growing over time, profit is growing over time. So monopoly profits are this 1 plus g to the power of t times. So that's one extra thing we might like to include in our model, demand growing over time. Another thing we might like is exit of firms. Okay, firms don't live forever. Sooner or later, I don't know, the guy who started the firm dies and he doesn't have any kids, so the firm gets liquidated. For all sorts of silly reasons why firms exit. So let's just model the probability of a firm exiting as just an exogenous shock. Okay, so suppose each period, for some probability h, that the firm is hit with a death shock and exits the market. You're looking scared?
I just don't like the term.
For what?
Don't worry.
The death shock, yeah. And we're going to make our life a bit easier by assuming that once firms die, they're immediately replaced by another one. Okay, so...
Selling your firm on.
Pardon? It's a bit like selling your firm on. It's, you know, it's what happens. You see firms exit for exogenous reasons and then mysteriously another one appears. You know, I don't know, computer games consoles, Sega exited, okay, and PlayStation entered very shortly after Sega exited. Or Microsoft entered after Sega exited. Okay, so we're going to have these 4 elements. We're going to have the growing thing over time, growing demand over time, the def shocks, and the real interest rate into the discount rate. So, putting all of these things together, if you don't deviate, you set the monopoly price, then today you get pi m over n. Tomorrow you're discounting by 1 over 1 plus r. Okay? But demand has grown a bit. Okay, demand has grown a bit, so your profits are a bit higher. But there's a probability h that you've died and exited. Okay, so there's a probability 1 minus h that you're still alive. Okay, so this is the term for your profits tomorrow. Period after, again you're discounting by another period. Demand has grown again. We're now 2 times you could have died in the meantime, so we've got 1 minus h compared to 2. And then we've got the base profits. Okay? So these are the profits you'd make if you don't deviate. If you do deviate, again, just as before, you get pi m today. And if we compare this equation to the last equation we had, okay, pi m over n plus beta times pi over m over n plus beta squared times pi m over n, etc. This equation is just the same as it was before if we set beta to be equal to this term. Okay, if we set beta equal to this, 1 over 1 plus r times 1 plus g times 1 minus h, then this is pi m over n plus beta times pi m over n plus beta squared times pi m over n. Okay, so behavior in this complicated model in which we have growth, we have def shocks, we have a real interest rate, it's just the same as behavior in the original model when we set beta equal to this expression. Okay, so using what we found before, we found that beta had to be bigger than n minus 1 over n. And if we interpret beta as coming from these things, then we need this expression here to be bigger than n minus 1 over n. Okay, so what do we see? Well, you're more likely to get collusion when interest rates are low, when growth is high, and when firms exit rarely. Okay, so this makes sense, right? You often see collusion at times of growth. During times of high growth, you see high prices. Firms are able to get away with collusive behavior.
Can you repeat the last bit about exit? The early exit.
Yeah, I said it was decreasing in this exit rate. Okay, because if the probability of exit is high, if h is high, and this is low, so you're less likely to satisfy this inequality. So, got a minute left. So let's do one last addition to this model before we finish. So we've had a growing demand. Demand was growing over time, but we've kept the number of firms fixed. And you might think that that's a bit implausible, right? If there's a fixed cost of entry, then when demand is high, you expect more firms to be entering the market. So what happens once we allow for free entry? What we're going to do is we're going to make a guess that the number of firms is just growing at the same rate as demand. Okay? Remember, this wasn't true for Cournot competition. In Cournot competition, it grew more slowly. But we're going to guess that it grows at the same rate as demand. Then all we have to do is go through and replace pi m over n with pi m over n times 1 plus g to the t. Okay? Because so period 0, the first period for n firms, the next period demand is being split by n times 1 plus g firms. The period after, demand is being split by n times 1 plus g squared firms. Okay, assuming that the number of firms is growing at the same rate. So why is this a good guess to have made? Well, if we look at what's happening to profits, for profits, aren't going to be growing over time, okay? Because the 1 plus g here and the 1 plus g there are cancelling out. So my profits today are going to be the same as my profits if I entered in 1,000 years. Okay, thus if the fixed cost of entering the industry, you expect the number of firms to grow like this. Okay, so you can do the same thing again. This model is just going to be equivalent to having beta is 1 over 1 plus r times 1 minus h. Because these 1 plus g terms are cancelling out. Okay? The growth in demand is being cancelled out by the growth in the number of firms. So if there's free entry, then we moderate the conclusions a bit about the impact of demand growth on the likelihood of collusion. Okay, so if there's free entry of firms, we expect the free entry of firms to cancel out the demand growth. So we don't expect demand growth to have any impact on whether or not you observe collusion. Okay, and let's stop there.